Okay, Crewton Ramone's House of Math. Okay, so as you can see, we had quite the little village going on here, but up until just recently, when somebody, we won't mention any names or anything, happened to knock over the board and a lot of stuff went collapsing. But anyway, that's not the point. The point of this video is supremely simple subtraction. 1 is 5 and 1 is 7. Right?
Yeah.
Okay.
Too easy.
Now, too easy, isn't it?
Yeah.
Okay, so we'll just start with this one. And we started off with raisins. Okay, look, I'm not going to even put symbols right now. It takes too long, so we just go through a whole bunch of them fast and just hear it.
You don't have to go symbol-y.
Alright, get all symbol-y on me. Alright, so let's start with the next highest one. Okay, so if it was 13 raisins and I ate 3 raisins, how many would I have left?
13 raisins.
Tell me.
3.
I would have 3 left?
Oh, no. You would have 10 left. 10 left.
Alright. You meant to say 10?
So it would be 1 for each of us. If it was cookies, it would be 1 for each of us.
Oh, wait a minute now. Oh, if it was 3 cookies, what about the 10? What if it was 10? How many would each of us get? Nope, we're turning into a division lesson.
Each of us would get,
How many would each of us get if there was 10 cookies?
So what do you like?
What do you think? Use some blocks and break it up to see how much would each one of us get. I'll give you a big clue by giving you the 3s. There's 3. 3 for you.
That'll be for me.
Give me my 3.
Ah, you're right.
3 for me. How about him? Does he get 3?
No.
Oh, put it there. Just because you don't want to share with your brother. Okay, oops. So I would get 3, he would get 3, and now how much does each one of us have?
3.
And so how many cookies total do we use up?
10.
Do we use up 10?
No, 9.
Okay. So there's 1 cookie left. What would I have to do to this cookie to make it fair?
Split it into 4.
Into 4?
3.
Why would I split into 4?
Forever.
Oh, okay. For sure. But she's not here. We're just talking about the 3 of us. Okay. Now, so each one of us would get 1.
Yeah.
Right? 1/3. So we get 3 and a third. 3 and a third, 3 and a third, 3 and a third. We just had a joke about that. Anyway, okay. So now, but let's get back to this. Okay, so pay attention and answer my questions. If I have 14 cookies.
What's 13?
The greatest thing.
What's 13?
Oh, your hair is just a wreck. Anyway, so if I had, okay, there we go. It went back down again. If I had 13 cookies and I ate 4, how many's left? So what do I add? What do I add? There you go. What does 4 want to be?
10.
What's it need?
6.
So I add 6. How many do I have then? If I have 13 minus 4, what do I have?
9.
Very good. Easy, right?
No.
Okay, so pay attention.
No.
I'm gonna just pick another. What if I took? I had 13. I ate 8. I ate 8. What am I gonna add?
2.
So what do I have?
5.
See how easy that is?
Yeah.
Okay, so what's 13 minus 8?
14 minus 8. 5.
Okay, very good.
5 alive.
Now, what if I had? Let's make 14 now.
That's easy.
That's easy. All right, so let's say I had 14 and I took away 5.
Take a little there.
Okay, so take it out of there.
Yeah,
what do I add?
5.
So what do I have?
4 and 5 makes 9.
Okay. Stop. Just tell me the answer. All right. Now, we're no opera. We're not no singing. We're not doing opera here. We're not doing musicals. A little too metro for me. All right. So now, how about if I took away 7? What does 7 want to be?
10.
What does it need?
3.
So what do I have?
7.
There you go. Right. Simple.
7.
Right. 7 minus 7 is. 14 minus 7 is 14 because 7 and 7 is the same as 14. But you see how a lesson on subtraction is actually a lesson in addends. This is why addends are so important. All right, let's try it again. Yeah, I'm talking to the people that are watching this. All right. assuming that anybody watches these. Alright, so... actually, they do. Alright, so now I have 15, and I take away, say, 8. What am I going to add?
If you take away 8, you have 2. You add 2.
Okay, so what is that?
8.
I know, and I add 2
7.
to the 5. What's 2 and 5?
7. 7.
Right. Okay.
I don't remember.
See, the older boy has got these pretty much memorized. The younger boy still has to do a little thinking.
Yeah.
So now let's just do a couple. And that's why we build these walls, and there were all kinds of things going on here earlier. But this is the whole point of that, so that they don't have to think about it. They just know. Let's do a couple of quick ones. Not for you. For you. 5 and 3. How many?
5 and 3, 8.
Very good. 5 and 1.
6.
That's easy, right?
Yeah.
All right.
Too easy. 7.
Very good. Before I can even ask the question. All right. No, that's good. Now how many?
That is
3 and 2. Just tell me the answer.
It's 3 and then you have 2.
Mm-hmm.
That's easy.
What is it?
3 and 2. It has to be 6.
6.
1, 2, 3, 4.
He's looking at his fingers.
5.
You meant 5. To make 6, what do I need? Oh, don't feel bad. It's okay. Right? Okay. Got it? All right. Now, so let's do a few more of these. What if I have no building yet? They want to go back to playing with the town. But hold on a second before we do that. 13, and I'm gonna take away. Oh, I don't know. 8. What do I add every time?
2.
2. So what do I have?
5.
5. Right?
Mm-hmm.
Okay. Now let's change the number, and I'm gonna make this 16. And I take away 8. What do I have?
2.
Still gonna be 2, right? Just add 2. Whenever I take away the 8, it's out, right? If it's more, it's always right. So what do I have?
2.
And total
6. 2 and 6.
is.
Hello.
Tell me the answer. Don't look to your brother. Tell me. Count it then.
1.
See, and this is again still at the age of 5, have not broken the habit. How much is this?
6.
So do I need to count from here, or can I just say 6, 7, 8? 6, 7, 8. But you'll see that they always want to start from here. 1, 2, 3. It takes too long. We already know this is 6, 7, 8. So you always start with the biggest one first. When I'm counting, watch this. Quick ways to learn how to count. And like I said, you have to train them to do it. They don't just do it naturally. This is where the teaching comes in. What's the name of this one?
2.
What's the name of this one?
7.
Now, if I'm going to count this one, why would I go 1, 2, and then start from here and count all 7? Why not just start at 7, 8, 9? Always start with the biggest one first. You know this is 7, 8, 9.
I was about to say 8, 9.
Right?
Mm-hmm.
But you'll see that kids want to do 1, 2, right? And then they'll count all these guys, and it takes forever. That's all addition is counting fast. Multiplication is just counting fast, right? Counting fast. 3 and 3 is how many?
6.
And another 3?
9.
And another 3?
12.
See?
15.
Instead of having, like, when you were little kids, when you were a little bit, you'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It takes too long.
And then by the time I
Okay, so watch this.
by the time I was 3, I knew it.
Yes. You're getting better and better at these. What's 7 and another 7?
14.
Okay. See, because you've got that memorized, you
And
don't have to go
another
7 takes another, and see, we can just do it with your fingers. 7 takes 3, see that? And there's 4 left. So what do I have there? I have a 10 and 4. 14. Now, 7 and a 14 and another 7.
21.
Very good.
7, 14, 21, 28.
See, that's because you've got them memorized. Alright, so now let's do this. Ooh, let's get see. What's 4 sevens?
Ooh.
What's 4 sevens? What's 4 sevens?
4 sevens?
Mm-hmm.
28.
Very good.
28.
Now here they are, 4 sevens, 28. See, and that's the next progression where they can count 7, 14, 21, 28, and then knowing that they've counted 4 of them. Okay, and there's no magic where we don't have 4x7 turns into 2, 8. We understand that we're counting 4 sevens. Or 7 fours. If you use your imagination, you can look in there and see that we actually have
That takes too
4
long.
sevens. Really? Yeah, but it's faster to count, right?
Try sevens.
Okay.
The harder you get, the faster it is.
Yes, and the higher the numbers are. Okay. So now at 28, I add 7 more. What happens?
We have 5, 7.
Ooh.
What is it? We have 5 sevens. How much is that? Okay, what does 8 want to be?
10.
What's it need?
2.
So I take the 2 out of there. See, am I covering the 2? How many's left over here? If I take 2 out of 7.
6.
Look again, if I take 2 out of 7.
5.
That's why the addends are so important.
35.
35, very good. Okay. Correct?
Yeah.
And
That's
I
why
put 5
that's why
right
I make
there.
you build walls out of 7s. Because I know that this right here cannot fit a 6. Can't do it.
It's overgrown.
It's overgrown. It's too much. You can see it there. Wait, let me go down there. You can see it, but it's too much. Okay. So if I have a 2 there, what's going to fit there perfectly? Put the block that's going to fit there perfectly. There we go. Just stick it on there. Okay, I cannot stress enough how important the addends are to making math easy and accessible for any child. You'll see teenagers that don't have their addends down. Alright, so now we just do the opposite. I have 35, I add another one. Now what? So 35 and another 7. What's 5 want to be?
10.
What's it need?
5.
There we go. So I take the 5 out. What's left?
3.
What? I take a 5 out of... We just talked about it. I took a 5 out of 7. What do I have left?
2.
2.
So what do I have?
That's just too big.
If I have 35 and now what's the next one?
42.
42. I make a 10 and there's 2. Right?
42.
42. So let's count backwards. Let's count again. 7, 14,
21.
21.
49.
We're counting these. You're right. But let's count these. 7,
7. 14. 21. 28. 35. 42.
then what? Just like you said, is
49.
49. And look, what shape is 49?
Square.
Square. So what's the square root of 49?
7.
7.
Easy, right?
Easy.
Right. Learn a lot of math at once. It's more fun that way.
Yeah.
Okay. Crewton Ramone's houseofmath.com broadcasting to you live from Math City here at... Alright.
That was funny.
Yeah. You have fun?
Yeah.
That's always fun.
And the winner, 24.